some misconceptions which are associated with resonance. When you have switched the position, now the left oxygen is dancing and the right oxygen is not very happy. Sounds complicated? Let's decode it one by one. Hello everyone, my name is Sahaj. Welcome to ATP STEM. In today's video, we will be taking care about resonance. Resonance is an important concept in chemical bonding and we encounter it again and again going forward in organic chemistry as well. So let's start. Towards the end of the video, our aim will be to get complete clarity on resonance and we'll try to debunk some misconceptions around resonance as well. So let's get started. Resonance, whenever we are starting resonance, there is a common term which we encounter and it is delocalization of pi electrons. Actually, this is just one aspect of resonance. Conceptually, how do we understand resonance? Resonance takes place whenever there is a requirement of making more than one Lewis dot structure to explain a molecule or an ion accurately. So one of the snippets from NCERT says this. Let's go through it. According to the concept of resonance, whenever a single Lewis structure cannot describe a molecule accurately, resonance takes place. Those Lewis dot structure, they should have similar energies. The position of atoms, basically the nuclei, should be same, and the total number of bonding and non-bonding electrons, they should remain same as well. Sounds complicated? Let's decode it one by one. I have taken an example of nitrite ion and we'll try and understand resonance through this. Okay, let's start. I hope you guys are comfortable making Lewis dot structures. If not, please write in the comment box. We will make a video for making Lewis dot structures as well. Okay, so let's start. Nitrite, one of the Lewis dot structure I have made. Left hand oxygen, you can see it has a negative charge. It carries the burden of negative charge. On the other hand, the oxygen is having a double bond. Doubly bonded oxygen has no charge, very happy. On the other hand, singly bonded oxygen which carries the negative charge entities are not very happy. This oxygen is crying because it has a negative charge on it. So can we switch the negative charge and double bond? Of course, yes. Those oxygens are identical. So are we able to make more than one Lewis dot structure? We have made two Lewis dot structures here, right? So is the resonance taking place? Yeah, according to the definition it is, right? Let's check. What is happening? Oxygen with the negative charge, not very happy, crying, huh? On the other hand, oxygen with double bond, no charge, elated, dancing. On the other hand, if we see oxygen, when you have switched the position, now the left oxygen is dancing and the right oxygen is not very happy, right? So can we make an average structures out of them? Let's see. An average structure we will make. The pi bond got shared by two nitrogen oxygen pair. So that one pi bond got shared amongst the two. Delocalization of pi bond is going on. Pi bond is not localized over one nitrogen oxygen pair. It got delocalized, right? On the other hand, the negative charge on oxygen that got shared as well. It's half and half on both oxygen. Total negative charge on the ion is -1, shared by two oxygens. So they are sharing the burden of negative charge and the happiness of double bond as well. And we know by sharing the sadness decreases. By sharing happiness multiplies. So this is what is happening. Oxygen, when they shared the sadness, both became relatively happy. On the other hand, what happened to the double bond? Double bond also got shared. So now neither oxygen has a double bond or a single bond. Both of them have bond order is nothing but effective number of bonds. They have bond order of 1.5. Right? And what is the charge on one oxygen? This value of delta, it's -1/2. None of the oxygen has complete -1 charge. Both oxygens are sharing that -1 charge, effectively having -1/2 and -1/2 on both of them. So this is resonance. It is delocalization of pi electron. So this pi electron which was localized here and the pi electron pair which was localized here, it got delocalized over two nitrogen oxygen bonds. All right. Resonance always leads to stability. Okay. So this is why it is happening. Now let's go through this. Some misconceptions which are associated with resonance, and one by one we will debunk them. Okay, let's start with first one. Canonical structures, the individual Lewis dot structures, they don't exist in real life. It's not like this that 50% of the time the first structure is there and the other 50% of the time second structure is there for nitrite. Both of them never exist. Actually, 100% of the time nitrite is in this structure. They are not interchangeable structure. You can make these canonical structure on paper, but do they exist in real life? No, not at all. What exists 100% of the time? This is the eternal truth. This is called resonance hybrid. The average of all the Lewis dot structures. Okay? The idea is this compound, the nitrite ion, 100% of the time exists in this entity, resonance hybrid. So canonical structure, they have no real existence. Okay, so this was a common misconception. I hope this is clear now. Second, molecules does not exist for certain fraction of a time in the canonical forms. No, it does not happen. So during the video, I said as well, 50% of the time, the ion exists in these two forms. No, not at all. These have no real existence. 100% of the time, molecule exists in the resonance hybrid. Okay, so resonance hybrid is the eternal truth. On the other hand, the canonical forms, you can just make them on your sheet of paper, but they don't exist. All right, okay. So let's move to the third one. There is no such equilibrium between canonical forms. They are not interchangeable amongst each other. Okay, so this A form cannot convert to B form and B form cannot convert back to A form because they don't have any real existence. All right, I hope that is clear. Last one, the molecule as such has a single structure and that single structure is resonance hybrid. So there was no structure in which one oxygen was very sad and the other oxygen was dancing. That was not the case ever. Always oxygens were smiling. Okay, so that is the idea. Bond order, the bond order between nitrogen and oxygen, it was never 1 or 2. It was always 1.5. Okay. One very popular structure for resonance, let's take benzene as an example. So benzene, we can make two canonical forms. I have interchanged the double bonds. Let's check. So here, if we take this individual structure, bond order between carbon and carbon seems to be 2. Here, bond order between carbon and carbon seems to be 1. So it switches between 1 and 2, 1 and 2. No, it's always 1.5, the average. So this is the real structure of benzene which exists. Benzene never exists in this or in this. Okay. I hope you understood the concept of resonance. For more such videos, please follow ATP STEM. Until next time, take care. Thank you.